Yes, why do we need to do some data mining, and then what are the various processes in the steps, and yeah, the algorithms and so on. And they're actually very important, and it's supposed to be one class, one full lecture for one semester. Yeah, but actually uh, professor just decided to arrange it this way, so we have to brush some things inside. Yeah. So we cannot pretend that this is, or say that this is all about data mining. No, there are people who do their master's degree so just in data mining. So yeah, but each time before you think about data mining, because in software engineering, when you want to start, you start by application development. You always think about where to keep the data. That is why in the beginning you start by, I think everybody start by very simple algorithm, adding two integers, displaying this message, and so on. Yeah, and after that, you now go to application level. Application level of it, you have to connect to a database. Database is a set of information that are related. So that's why we talk about relational database and so on. Yeah, so in software engineering, you see that always like that. But now, is there's something that's very important you need to know. It's a knowledge discovery in database. So we define the database in a simple way, in undergraduate, like a set of information that is interrelated somehow. Yeah. And you know how it works in some kind of structures or tables and everything and so on. And then some languages like SQL, MySQL, and so on to try to communicate with the database. Yeah. So, but to understand data mining, you have to understand exactly how the knowledge discovery path happens. So it goes from that database, first of all, yeah. And then from the database, in this case, you see that data mining is just a path, or a specific part of it. Yeah, but there is this Fayad definition that is very famous. Yeah, for him, he defined data mining. Data mining, so some literatures can define it as data mining, or some people can look at it as knowledge discovery database. But still, in he cited that it is a non-trivial process to identify valid, novel, and potential useful and ultimately understandable patterns in data. Yeah, so when I talk about non-trivial, it means that it goes beyond statistical data or just normal SQL query, because SQL query has some kind of format. Yeah. And then some valid means that the pattern must be whole for unseen data. It therefore means that if I've done this with this data, I can replicate it with some other kind of data, for example. And then it has to be novel. It means it should provide some new insight. It has to be useful. It means it should inform about decision. You have to be able to make a decision. Understandable, it means that people can understand what it means. And then for instance, you see that in this process, so we have our local data here, but still, it's find out something, it's a knowledge we need to give, some interpretation about data. So most often, I can take an example here, and I will give an example, if just a real life example. So just to give some example about this. Okay. So this is something that is written, so we can call it in research or in news or information or whatever. It's raw normally. They say John has an accident, for example. So if they say John has an accident, actually there's no knowledge here. Why? Having an accident is something sad. It's supposed to push you to react. But you are not reacting. Why? Because you don't know John. Okay? But if imagine if they say your brother had an accident, you have to react to that. That is why the raw data and the knowledge has to pass through some kind of meaningful process. So they have to identify a target, they have to process it properly, and also find a pattern to get some particular information. So this one remains basically at the level of, this is still at the level of news. They call it news, like the journalist is talking. It makes no significant difference for you. But once it affects you, if you can give a meaning to it, you are extracting some knowledge. And if you extract knowledge, then it makes it totally different. It makes a process. So I gave this link. So I wanted also you to listen together, but you can follow on your own. Because I have two links here that I wanted to listen, but it takes more than bread and beer we have how many times? It doesn't appear at all. So nobody makes this bind. And then but butter and milk in transaction 1, and then which transaction again?
4.
It's transaction 4, yeah. So we have it 2 times. Butter and diapers, we have it transaction 4, so 1 time. Yeah, we have butter and beer, and then milk and diapers. Yeah, milk and beer, and diapers and beer. Diapers and beer, it appears here and also here. Yeah. So for example, this is how we find the support. But you know, the support is supposed to be with some number of transactions, but we don't need it. Because all of them, it's meaningless to compare 3 on 5, 2 on 5, everybody on 5, okay? It doesn't mean that the support have changed formula, no. It's just that all of them are having the same denominator, so it's not needed in this case. So I have the 2 set items here. I need to come back again because something happened here. I have to remove this guy. Yeah. So now, for the 2 items set here, I have to come back again on my support threshold. Yeah. So on support threshold, everybody that is less than 2 is disqualified per my condition, initial condition. So these guys are qualified, 1, 2, 3, 4. All the rest is disqualified. Why? Because I want to make a rule for people who buy at least 2 products. But they didn't satisfy it. I didn't find anybody in my data set that satisfied this rule. This is why I have to remove it. It's unnecessary. Okay? I'm digging inside my transaction table. You will see the conclusion that we'll make step by step. Yeah. So in step 2, I can keep bread, butter, milk, butter and milk, diapers and beer. Because at least they satisfy my expected threshold, for example. So at this point, you can go to the third item, 3 items if you want. Yeah. And 3 items, if you want to do that, this is what you have to do. At this point, you have to identify the single elements that were returned. So we have bread, butter, what again? Milk, and beer, and what again? And diapers. Okay. Yeah, for example, we have these 5. So if you want to go to the stage, what do you have to do? This is data mining. You know the algorithm, so you have to define as much as you want. So if you want to do, you have to take these 2. So I take bread, butter, and I add this milk. This is 1 set. And another one is this one with beer, with diapers. And the next set now is, I start from here. Okay? Butter, milk, and he's already there. Butter, milk, and beer. So you take these 2, plus 1, plus 1, plus 1. Anyhow, you have to make the association. Yeah, so if you take these 2, you add 1. You take these 2, you add this. You take these 2, you add this. And so on. And then you take this one and this one. For example, I think that's the best way. This, and then you add this one. And then this and this, you add that one. You take this and this, you add this one. Yeah, to make set of 3. So you have to define all the possible set of 3 and come again and find their support. It means that the set of 3, you have to ask yourself, in how many transactions were all these 3 items purchased at the same time? You must ask yourself that question. Because it gives you more than 10 elements here. But for each element, you have to find the support. And once you find the support, you need to disqualify those that don't support your threshold.
For 2 set, threshold is 2. For 3,
Threshold is always 2.
but
I think there's some, say,
Just one set that qualifies. Like bread and butter.
okay, for this step one, there's only one set that qualifies.
That's what it looks like.
Just one time. Just one time. And all the others, twice. All the others are less than 2. Yeah. So always remember that each time you are doing you are generating some k item set, you must generate a k item set considering the minimum confidence. The confidence score, I will show you how to use it, but considering the minimum support. So here the minimum support was how many? 2. This is why we removed this one. Okay? Here the minimum support is still the same, it did not change. It's 2. So we remove those that are not up to 2. What I'm saying is this. At the third level now, the K item number 3, you have this kind of set, bread, butter, milk, and so on. So you define them all like this. I said you take 2 plus 1, 2 plus 1, 2 plus 1. And then you take this 2 plus 1, and like this. So you make the same combination, this, and you add this and this, and you add that. It will give you roughly 10 elements. But within the 10 elements, you need to ask yourself, when was bread, butter, and milk bought all at the same time? You have it 1 and 2, irrespective. But look at bread, butter, and beer. Bread, butter, and beer, nowhere. Only here, 1 time. It means that anyhow, this one is disqualified already. For the election in the next stage, you don't return it. Okay? And then the other one is bread, butter, and diapers. Bread, butter, and diapers. Just once. So it will not also work. The other one is bread, butter, and beer. Bread, butter, and beer is even 0. So if you make this table for the 3 item set, if you make a table for 3 item set, you will find out that there is it's only one element that is qualified for this. Are we getting this? Yeah. So that is why I have to use the second rule. Why? Because the algorithm states this. You have to do this until you have no new candidate. After 3 times, you cannot continue. You have to stop. There's no way to generate again. Okay? Yeah. Leo, you don't understand? Okay. Yeah. So let's look at this, please. Now I want to use my confidence rule. Yeah. I must have to remember this. The confidence of A towards B is equals to support of A intersection B all over support to A. So it means that the confidence, and what's the meaning of this? I want to find how confident a candidate that bought this A product can likely buy the B product. So in confidence, it's not symmetric equation. It's not the x1 equals to x2, meaning that x2 is equals to x1. No, it's not like that. Okay? It doesn't work like that. It's not some kind of symmetric equation, because you will see the confidence from A to B is different from B to A, because it has to change here in terms of support. Yeah. So now, in step 2, I have these items. We clearly kept this: the bread and butter, the bread and milk, the butter and milk, and the diapers and beer. This is what was qualified at the end of that stage. From here, we want to make the rules. So we finish already generation, because the next step did not give us significant information. I want to make a rule based on 2 items bought. So now I want to make a rule, and then, so I have to generate the rule. Generating the rule means I will use the confidence, the minimum confidence, to make a rule. For example, we said if some people do this transaction, it means that a rule can be somebody who buys milk and bread will likely buy butter. We just said it like that. But we are not sure. Now we need to check it carefully. So the first thing I need to do at this point is I have to find the confidence of A towards B. For example, you know what it is? It's a support of A intersection B and all over support of A, for example. So at this point, I need to check very well. What is a support of A intersection B? Is how many times those two products were bought together. I want to make rules now. I've passed already the item generation of the algorithm. I'm making some rules now. So, example of calculation here. How does it occur? Let's take this one. This one. You remember the 4 set? You have 4 sets. So we take just this first set, bread and butter. So in bread and butter, we want to do something. In bread and butter, we want to check the confidence from bread to butter, for example. From bread to butter. So the confidence from bread to butter, it gives the support bread and butter. I need first of all to find the support of bread and butter. How much time were they bought together? Bread and butter, I need to count here. Bread and butter 1 time, 2 times, 3 times. So that is why I put 3 here. Okay? It was bought 3 times. And I also need to check on the support of, is bread towards butter? So I have to find the support of bread. Bread is in how many transactions? 1, 2, 3 transactions. So that is why it gives 3 on 3, which is 100%. But I'm not using the support condition again to do elimination. My new condition is what? To generate the rules, I have to use the minimum confidence. It's 70%. So 3 on 3, it gives 100%, which is 1. So it's qualified. I can make a rule with this one to improve my cells. Next step, I have butter and bread. It gives same. But let's look at this, the bread and milk. For the bread and milk, you have to find for the support of bread and milk. Support of bread and milk is, yeah, it appears 2 times. I think it's a transaction 1 and this one, transaction 4. So it appears 2 times. And then I need to look now at support of milk only. Milk is 1, 2 times. So it gives milk to bread, it gives 2 on 2, which is 100. But bread to milk, it gives 2 on 3, because the bread appears 3 times, which gives 66% confidence, which is lower than what we want. So we don't want to make a rule here, we disqualify this. So this is disqualified. It's same here, butter and milk. Butter and milk, so you have to find butter and milk, they are bought 1 times, 2 times, yeah. But milk was bought how many times? Milk is 1, 2 times also. So you have 2 on 2 here. But butter and milk, butter was bought how many times? You have butter 1, 2, 3 times. Yeah, so it makes 2 on 3. This one. So it disqualifies this also. It's less than the minimum confidence score. Yeah. So everything that is above 70%, we keep it. Because it's what we set as standard goal. So at the end of the day, the item that respect the conditions are bread and butter, this, bread and butter, butter and bread. You see, they are different. Look in this case, bread and milk is not the same like milk and bread. They are totally different. That is why I said it's not a symmetric equation. A equals to B, in this case, doesn't mean B equals to A. You have to count, find the confidence on its own, and then from here you see we have some disqualified cases, 3 of them, and we remain with 1, 2, 3, 4, 5. So there are 5 cases that satisfy our rules. Now, the rules are like this: bread, butter, butter, bread, milk, bread, and milk, butter, and beer, diapers. This is what we finally found when we respected the rule of having a support of 2 and a confidence of 70%. So it gave us this final result in only 5 transactions in a store. Within 5 transactions and less than 6 products, we are able to make this rule. And what is direct implication? The direct implication is that of the association rule is that using this algorithm, you can have some certain items strongly co-occurring in transactions, so you know exactly what appears a lot in transactions. Yeah, and this can be used for decision making. So maybe if you want to order, you know mostly what you need to order more frequently. All these items are more likely to be bought, for example. So it have to help you in marketing, you know what to advertise, what people can like, and so on. Inventory management, recommendation, for example. People like this, so you can use it for recommendation. But let's go deeply again into it. The fact that I have a confidence of 100% for bread and butter means that every time a customer buys bread, they also buy butter. Okay? Every time a customer buys bread, he also buys butter. So I have to, an action, physical action is that I have to put the butter next to the bread in the stores. So each time I have some butter here, I have to put it beside the bread. Because I know already for sure in the transactions that there are 2 items that are going together. I don't need to stress him. I make customer free to understand or to buy it. So we go when he sees, and then I can also make some bundles of bread and butter for transactions, for promotions. If I have a discount, I sell these 2 things together. I know they match. But think about it, cookies and beer. They have no relation. It was disqualified. If you make that kind of promotion, it doesn't work. Okay? Yeah. Also, it's the same with butter and bread. So customer who buy butter also buy bread. So they are somehow some kind of complementary products. And then some milk and bread at 100% means that if the milk is purchased, then the bread is always included. So you have to bundle the milk with this for breakfast items. You can put it on one side, and then, yeah, you can have to do some promotion. You see these actions that are coming are actions that are coming from the analysis of the data. Do we get it? It comes from what we analyze in that data. And here we use just one algorithm, and with a simple, just 5 transactions. So just imagine, you have to run this for 1 month transaction in a supermarket, like Shinseki department store. Let's just say Top Mart. Yeah. So if they give you Top Mart sell records to make rules, it's complicated. Yeah. But in business, you can use all this in business for some product placement, for example. So some items with strong occurrence can be together. Like in this case, bread and butter, we can put them together. Yeah. Then cross-selling opportunity. So if you want to maintain customer relationship management and so on, then you have to look at that. And then also customer behavior understanding. Yeah. See, in this case, it seems like the beer and the diapers may not highly be purchased together. Yeah. It doesn't always give you only positive recommendation. You also see what is not good to do. Yeah, there's no need to try to force some. Yeah, there are non-obvious purchases. People will not likely buy. People who buy diapers don't frequently buy beer. No need to put them on the same place. Or no need to mix them for some promotion. So you cannot make a promotion where you sell this package together. Yeah, it doesn't work that way. So if you are trying to build some binding and discount and so on, you have to use some this kind of thing. But just imagine we use just 5 transactions and 6 items to have this. So imagine you have some more and more. It takes a lot of time. Yeah, a lot of time. That's why you need now to implement this using some libraries. Yeah, some libraries. But this is exactly what it is, data mining, trying to dig into it and understanding, yeah. So we did manually, but you can have some practical implementation of this. And until you have some business implications in real life also. Okay, so let's look at another association rule mining stuff. And so we look at another way, another method here. So the other one, you see, it's taking some little time to understand, with some 30 minutes or 20 minutes to explain step by step like that. Yeah, that is why I just want you to understand that if we were in uh, in the data mining class, just a data mining class, then we have a lot to do. We need to understand how it works on small set. We understand how to do the abstraction and how to implement it step by step until we have a final solution now. Yeah, but now our course is squeezed and only 5 lessons, so I'm just trying to rush on. I hope that next semester it changes. Yeah, in a way I prefer a very clear protocol like that. Yeah. So another algorithm now is the FP growth algorithm. Yeah, that's a frequent pattern growth. Yeah, so it's some kind of improved of a priori algorithm by eliminating candidate progression, for example. So the principle is to compress the database into a compact prefix tree, for example, FP tree, and then do some kind of recursive mind frequent pattern, yeah, from the candidates. So in this case, you have the steps there, and then some also advantages above all. But when you want to implement this, so you have to look at some, for example, Python or R, yeah, to look at some rule to extract data from a data set. You can follow these papers. Here he will give you some basics about very fundamental knowledge about data mining, for example. And then the other papers also make some difference. But how do we do it again? So some other tasks where you can use data mining is about abnormality detection. Abnormality detection, like you have to identify some unusual instances. Yeah. You see, like for example, in our example, we also declare that some 2 products were not really good to be put together in terms of any promotion or any other thing. Yeah, it wasn't appropriate to maybe combine bread and diapers or something like that. Beer and diapers, for example. Yeah, so you also use it to kind of finding some unusual instances, yeah, outliers, and then you can see that in all the cases there are some tasks here that you have to do. But this and this, we really know what it is. We've practiced this so many times. So I really want us to focus, for example, on this. You see, this one is a focus on it, for market basket analysis, and then these are some kind of 2 examples of algorithms, but there are some other algorithms again, and then some abnormality detection, and then credit card fraud, and so on. Yeah. So we can look at that. But I feel that at least these 2, no need to focus more. I want to focus on exercise to be on this, or regression in the worst case. Yeah. So you see, in industrial setting, you can see already the type of things that you can do in terms of tax and some kind of examples. You still have the same kind of activities here that you can do, some dimensional reduction with PCA and so on. Yeah, abnormality detection and so on. So these are the typical examples of data mining. So I hope that at least at the end of today, you know what it is. You've seen the whole part of extracting knowledge from data, and you have seen exactly where data mining enters and what kind of technical algorithms are defined as data mining algorithms. So these are important things you need to keep in mind also when you're working. So I try to give some real world application here, like some market basket analysis, yeah, used by Amazon, for example. Yeah. So they try to discover some co-purchase patterns. What kind of thing people buy together, for example. So here they use some, you remember, so they use some association rule, a priori, for example, and then they can define a rule that people who buy milk and bread, they also buy butter, for example. But in medical imaging or in healthcare, we can also have some kind of disease diagnostics. So we can predict some kind of diabetes or cancer. Yeah, you can use any type of data set and support vector machine and so on. So these are classification algorithms. In this case, you have to get some high recalls to avoid some misclassified diagnosis. Because if the recall is low, then in some cases, you may have some misprediction and misdiagnosis also. Yeah, and the tools that you use here is some TensorFlow and so on. You know this one already. And somebody tried to work on gene expression before, genetic something, genetic data. No one tried this. Yeah. But you have some data set there, the gene expression, omnibus data. Yeah, and some other applications, like credit card prediction in banking. Yeah, so you have to do that. And when you look at, have you checked papers from cybersecurity? Have you seen somebody who is doing cybersecurity and AI? Intrusion detection. You can check, honestly. If you see the kind of paper they publish, even in high impact factor, you will not be, because this is how it happens. I feel like what is more important for them is their application area. When I went to Osaka one time for a conference, I talked with a Nigerian, he's in one university in Korea. I saw his publications, and when I look at that, I feel that we can easily do, but the only difference is that he applies only, because he does security. Honestly, he applies, we really suffer here. If you go far up to what I say, weekly supervised learning, all this is too advanced. He just applies some basic, but the problem that he's solving, since it's intrusion detection, yeah, detecting fraud and attacks on network and so on, yeah, it makes it more original. We look carefully at his presentation, look at the part that concerns AI. It's really basic. But because of the area, he's going high with his research. And that is why I try to say, last time, let's try to look at things differently. Yeah, especially with physics apply and material science and so on. Because we may stick on medical imaging, it's too advanced. So it's difficult each term. Yasin is trying, what will I in my model this term and so on. But maybe if you were doing fraud detection like that, maybe you have published already things, another very big one, you see, maybe. So I think that we need to think in that direction also. It's getting a little out of, even medical, see, business medical is better. Yeah, some kind of other applications. So there's also this customer segmentation stuff we discussed about recently. Yeah, so, but let's mostly focus on, yeah, at least these three algorithms, mostly. So these are some kind of tools and framework you have to use if you want to implement this. Yeah, some for classification and clustering, you've used them already. Yeah, so GUI based, you have Orange and R programming also, and everything. So you have these tools that can help you to easily do this. Yeah.
Is R like RStudio
Yeah. So now you can also use some kind of integration in integration options. Yeah, so it depends on what you want to achieve. So if you have to connect with database, you can use SQL, Excel, and so on. Yeah, Jupyter Notebook for the other ways. But this one, I think everybody does that now. Yeah, how to, if you finish to do your model, how to deploy it, how to deploy it. But never forget about some ethical consideration. Yeah, how the bias in data, talk about some explainability always. Black box, how is it making decision? Is it fair? Yeah, is it fair decision making? What about the privacy, the type of information? Are there some private information leaking? And so on. So you always have to discuss this also. Yeah, and some regulatory framework. So each time you announce that you will have to deploy in real time, you must have to mention that you need to follow some regulatory framework rules. Yeah, especially for healthcare and finance. There is no way you can do without this, so it's important to do this. Yeah. So you can take this other assignment. Yeah, this other assignment, so it's some kind of practical activity. You take it for 4 weeks where you have to design some complete data mining project. So you have to choose whether in finance and health and retail. Please make sure it's not classification. Then it's meaningless. No classification. That's why. So you have to, first of all, what is interesting is the report. Yeah, the report. How you report the whole work. So please, you have to define the goal and describe the set that you are using. You have to select the pre-processing. It's totally different how you fix the data before doing the mining itself. So in mining, please don't do classification and clustering. It will not help us in this case because we want to target some at least conference or some kind of journals. Yeah. So try to follow associative roles, for example. Yeah, in a way. So it makes at least something different. Yeah, for us. Yeah. You obviously have to choose some metrics, but association rolling. You know the metrics already. You have the support, you have the confidence, and so on. Yeah, but all the others, is always accuracy, recall, and everything. Yeah. But in any algorithm you choose, there's a way to evaluate it, so you have to evaluate. So it's very important to discuss the real-life implication of the obtained solution. What are the real-life implications? It's important, so if you have them, you discuss the ethical considerations, and yeah, you suggest some deployment architecture, not deploying. Yeah, you don't need to deploy, just how you can integrate it in a real-life system. You just make some architecture, and from there it's fine. So this is all about what we have to do. So I'm still insisting that if it was a complete class, I'm sure we go step by step, lesson by lesson, deeply. At the end, we are able to do many things. But now it was shortened by the professor. Yeah, so we have to do very fast this way. Thank you so much. So do you have some other questions or discussion?